now from here what we will do, we will move on to the second level of classification, which is your chemical nature of classification. Chemical nature of classification, they could be classified into three categories. One is their organic origin, second one is inorganic origin, third one is carbon based. Okay. So, there are three different classes in terms of their chemical classification. In terms of organic nanomaterial, there could be dendrimer, micelles, liposomes and ferritin are commonly known as organic nanoparticles or nanomaterials. Okay. So, organic ones includes dendrimers, micelle, liposomes, ferritin. So, these are commonly known organic nanoparticles, and these nanoparticles are biodegradable, mostly non-toxic, and such particles such as micelle and liposome has a hollow core. So, if you see a micelle, it will be something like this. These are the lipid moieties or hydrophobic moieties which are making the micelle. So, if you look at the center, this center cavity is all hollow center cavity or the hollow core, okay, and also known as nanocapsule, and are sensitive to thermal and electromagnetic radiation such as heat and light, and they are also known as nanocapsules, and these are very important from agricultural perspective in terms of release of say insecticide, herbicides, pesticide, those all could be encapsulated inside and they could be used for slow release. Okay. So, these are also called nanocapsules and are sensitive to thermal and electromagnetic radiations. Okay. In terms of heat and electromagnetic radiation, in terms of light. Okay. So, these are some of the very unique characteristics make them an ideal choice for any kind of delivery systems, and this delivery system has a carrying capacity, its stability could be tuned according to our needs and requirements. Okay. Then comes your inorganic brother in that community, which includes your inorganic nanoparticles or nanomaterial includes metal based, you have metal oxide based, so metal based and metal oxide based includes mostly inorganic nanoparticles and nanoparticles that are synthesized from metals to nanometric sizes either by destructive or constructive methods are metal based nanoparticle. Almost all the metals can be synthesized into nanoparticle, and the most commonly metals for nanoparticle synthesis are aluminum, cadmium, cobalt, copper, gold, iron, lead, silver, zinc. And in terms of metal oxide based nanoparticles are synthesized to modify the properties of the respective metal based nanoparticles. And for example, if you see iron here, and Fe2O3, you have Al2O3, aluminum, you have different other such metal based systems which are there. This also includes a series of metal sulfide based, which will be dealing pretty frequently. Then you have rare earth based. So, these are all different kind of nanomaterial which are either metal based or metal oxide based or metal sulfides. Metal sulfides could be, say, if we talk about iron, FeS2. If we talk about rare earth, we will be talking about CO2 cerium oxide, FeS2 iron sulfide. We will talk about, say, molybdenum sulfide, MoS2, which is a material very similar to graphene oxide. Okay. Similarly, we will talking about some of the other sulfides where metal is represented as M here and sulfide is represented as S. So, there are different kind of sulfide compounds we will be dealing in the inorganic section, and then we will be talking about now the carbon based, which is a huge group. As a matter of fact, or the carbon based, and this is where a lot of these journeys have started. So, the carbon based nanomaterials are classified under fullerenes, graphenes, then you have carbon nanotubes, CNT, or carbon nanotubes, then you have carbon nanofiber, then you have carbon black, and then you have activated carbon in nano size. And in nano dimension. So, these are the different categories. When we talk about fullerene, we are talking about Buckminster fullerene. So, it is kind of a cage of carbon. It is something like geodesic dome. It's kind of a cage where you can entrap different kind of moieties like this. Whereas, if we talk about the graphene, we are talking about a two-dimensional sheet of carbon arranged something like this. We talk about carbon nanotubes, we are talking about a hollow tube of carbon something like this. Then we talk about carbon fibers, these are just like nanofibers we talk about, these will be the fibers like this. And then carbon blacks are nothing but particles, and activated carbon is also similar to the particles. Now, most of these carbons could be further functionalized or could be derived by functionalizing them with OH group. So, increase their interaction with water, their properties of hydrophilicity could be modulated by having functionalizing them with OH, and they could be derivatized as nitrogen doped. There are different techniques which have been developed deriving them through nitrogen dope techniques, and much of these carbons which have arise in nature normally has arose through geological era where most of the biomass through the ages, through millions of years, under high pressure and high temperature underneath the earth crust got transformed into things like coal, things like diamond, graphite, and if you take this material and follow the techniques of pulling out nanomaterial, you will see all these materials are filled with nanomaterials. In nature, we have graphite or graphene kind of stuff present in the coal. So, this has all happened through ages of exposing these biomass which are rich in carbon and partly nitrogen, little bit of a 16% nitrogen and other compounds in trace amounts. And this high temperature, no oxygen and high pressure through the ages have led to conversion of the biomass into some form of nanomaterial. The reason why I am highlighting this part is, while we will be talking about synthesis, you will appreciate that much of the synthesis which we will be talking about in terms of the physical mode of transformation, where we have to give mechanical pressure, heat, light, is nothing new, because nature has already made nanomaterials by exposing the raw material to high pressure, high temperature, lack of oxygen and myriad of other combinations of this. Only thing is that in the nature's laboratory, these have happened where time was never a constraint. Time always remained in almost infinite order, but in our lifetime, time is the only constraint. So, when we talk about synthesis, we had to emulate nature, and at times we have to become more smarter than nature in terms of compressing time, because we want to achieve it. And of course, such things to go at a large scale won't be that easy, because nature has produced them through many thousands of years. Okay. So, talking about carbon, carbon nanomaterial are one of the very promising candidate for decorating them with different kind of moieties what we wanted to deliver. Say for example, while I was talking about the nano ribbons, I told you that these are the different ways you can really modulate the nanofibers. Similarly, when we talk about nanocomposites, I told you. So, say for example, your core composite is carbon, and on top of carbon you are doing all these kind of decorations, say nitrogen, phosphorus and all these kind of things. It is possible, but of course one has to ensure when we are functionalizing the carbon like this, we have to ensure this functionalization of carbon leads to, when exposed to the area of delivery or site of delivery, it should be able to deliver easily without much problem. So, that is very critical. So, to summarize the different kind of classification nanomaterials what we have talked as of now, so they could be classified under two headings. either based on shape and geometry or based on their chemical nature. In terms of their shape and geometry, we talked about nano cages, a hollow interior porous material of 10 to 150 nanometers. We talked about nanocrystals. We talked about, and nanocrystals could be even a sphere, hollow sphere. We talked about nanobelts. We talked about nanofibers. We talked about nanoparticles. We talked about nanotubes. We talked about nanowires. Talked about quantum dots. We talked about nanocomposite, and I mentioned about nanodiamond and all other different forms of nanomaterials. In terms of their chemical classification, they are either organic based or they will be inorganic based or they will be carbon based. In terms of organic based, they could be either dendrimers, something like this, like a dendritic tree of a neuron. If you look at a neuron, it's something like this. Okay, this is an axon, and if you look at the dendritic tree, it is a well spread out, something like this. So this is what dendrimers are. Then you have micelle. I have already shown you the picture of the micelle. Then you have liposomes, which is pretty similar. And you have ferritin, iron binding clusters. Okay, and these are mostly biodegradable, as I mentioned, and these are non-toxic. And they have a hollow core, and they are also sometimes called nanocapsule in terms of when you talk about the micelle or the liposomes. And their properties or their degradation, their opening, it could be regulated by thermal or electromagnetic radiations. Okay. So, you can expose them to light, they may open up partially. If you increase the intensity of light, they will open up more. So, there are several modifications what you can do with these kind of nanomaterials. Then we talked about the metal based nanomaterials or the inorganic nanomaterials, and within inorganic we talk about metal based, where we talked about aluminum, cadmium, cobalt, copper, silver, iron, zinc, lead. Similarly, in terms of the metal oxide based, Fe2O3, Al2O3. Okay. Then you have zinc oxide, ZNO, copper oxide, CO. These are the different nanomaterials which we will be discussing in terms of our applications in agriculture. Then silver oxide, so several of them. Okay. Then in terms of the third category is the metal sulfides. We'll talk about them in terms of iron pyrite, FeS2, molybdenum sulfide, and any other metal sulfide, zinc sulfide likewise. Okay. ZNS. Okay. Then we will be talking about the rare earth like cerium oxide, or especially mostly lanthanide series, rare earth oxides. Okay, lanthanide series. So then the third category what we discussed is the carbon based system, and within the carbon based system, as we talked about fullerenes, graphene, which is fullerene is the Buckminster fullerene, it's a C60 and all those kind of very complex caged compounds of carbon, three-dimensional cage compounds of carbon, which is the nearest one which could be achieved was with the molybdenum, where you could have the strong cage of molybdenum. Okay. Then you have the graphenes, then you have carbon nanotubes, these are the hollow tubes, then you have carbon fibers, then you have carbon black, and you have activated carbon in nano dimension. Okay. And these could be functionalized with OH group. These could be functionalized with carboxylic group, depending on your requirements, what you wanted to use them for. They are functionalized with OH group for their solubility in water. They could be derivatized as nitrogen doped carbon material for different applications. So, this is the overall classification. Now, from here what we will do, we will move on to the synthesis of nanomaterial, where we will be talking about 3 different synthesis techniques: physical, chemical and biological origin. Okay. So, next we will move on to the synthesis. Thank you.